In our previous chapter 5.1, we are trying to describe the gas in terms of PV equals to nRT. This gives us the relation between the pressure, volume, number of mole, and also the temperature of a gas, and they will be changing with each other. But then this equation only describes the situation, but didn't explain why it will be like this. So that in 5.2, scientists are finding a way, a model to really describe the situation, to explain why PV will be equals to nRT in this way. And they are observing a smoke particle inside a small chamber, and they accidentally find out that the smoke particle is not at rest or falling by gravity, but then they are moving randomly when they observe under the microscope. So that the situation is like this. We have a microscope looking at a very small chamber. Inside you have a little bit of smoke particle, and then the smoke particle is being shined by a lamp so that it reflects light to the microscope so that we can observe. And this guy, the first guy to observe this, is called Brown, so that the motion, the random motion of the particles is called Brownian motion. And we try to explain why we can see that it is in random motion. The bright spots are smoke particles, so that the visible smoke particles are moving randomly. And why? It is because they are heated by invisible air molecules. And the air molecules are moving randomly, so that they are heating the smoke particle and cause the smoke particles also move randomly. So that this helps us to indirectly shows that in fact gas is made up of a lot of invisible gas molecules moving at high speed in random direction. So that we can see that the bright spot, the smoke particles, are having a zigzag path continuously, a random motion, and it is because it is being heated by air molecules from different directions, so that it is moving in. After studying this situation and think of there are invisible air molecules, then scientists based on this try to think of a model to explain, and this is called the kinetic theory, the molecular motion of gas molecules. And this theory is very important in DSE because every year it must appear. But then the lucky thing will be this is usually MC, but the unlucky thing is that this topic is very difficult at the very beginning, so that we will have to focus on this chapter. Very important topic in DSE. Then let's try to look at the detail, because this topic can help us to link up the macroscopic world. That means studying the measured quantity P, V, and then T, to the microscopic world that studies the motion of molecules. So that this helps us to link up these two things, the macroscopic and the microscopic, which is the temperature, volume, and the pressure can be linked up with the average Ke of the molecules. You can see we're talking about molecules here, the average Ke, and then the free space, which is also the volume of the gas. But then we are again talking about molecules here. Lastly, we talk about collision of molecules with the wall of container. The collision can help us to explain why we have the pressure inside a gas. In order to study the ideal gas, we firstly talk about the assumption of the kinetic theory of an ideal gas. So that what is the meaning of an ideal gas here? Please try to recite all this, because this is usually a MC. So that you have to somehow recite it. It need not to be exact wordings, but at least you know what is inside this several assumption. And I will put something that you need to recite by purple highlighter. The assumption of ideal gas here. Firstly, we have assumed that the ideal gas will have a huge number of molecules moving in random motion, so that you would not just talk about 10 molecules, but billions of molecules. Next, the size of the molecules will be very small and negligible when compared with the container. So that container is very big, while a molecule is just a very tiny point here. Next, the intermolecular attractive force are negligible. Then this will be resulting in that the gas will not condense even in very low temperature. Condense means from gas to liquid, so that it will be always in the gas state. It will never change to liquid state because there is no intermolecular attractive force, so that the molecules will not bind together. Next, the collision between the container and the molecules will be perfectly elastic, so that there is no energy lost. That means the gas will not cool down by itself. So that the gas, if it is 100 degree, then if you keep it in a container, then it will be kept at 100 degree. If there is no energy loss to the surrounding, it will not automatically cool down itself. And lastly, about the collision time, is also negligible when compared with the traveling time, because we have mentioned that the container is very big, so that after one collision, when we are chasing one molecules, it will not collide very frequently. It will travel through a large space and spend a lot of time traveling before the next collision. Then those will be the assumption of the ideal gas. And lastly, we will be talking about, based on those assumptions, based on this kinetic theory, how can we explain how a gas can exert a pressure on a container? And this is a very important explanation question in DSE. Please really recite it in great detail, every single word. Recite, because this is an explain question in DSE. We will start with, the molecules are moving randomly, and then they will be colliding with the walls of the container and rebound elastically. If we have an elastic rebound, there will be a change in momentum, because we may think of, originally this is moving with positive V. After hitting the wall, it is moving with negative V, so that we have a change in momentum. And a change in momentum will create a force, because force is equal to change in momentum over time. Hence, it will create a pressure equals to F over the area. So that this will create a pressure on the wall of the container. And at the end, the question may further ask you to explain, then why pressure increase? Then we may further explain. The gas pressure will increase if the molecules are doing two things. Firstly, it may be colliding more frequently. This is the first reason of greater pressure. The frequency increases. Or the frequency is the same, but then it is hitting more violently. That means the average speed is greater. It is moving faster, so that if a faster molecule is hitting the wall, obviously it is generating more force and then more pressure. Okay, so that this is how we have to use those exact wordings here to explain. And the key will be, make sure you know all those physics terms here. Can you see? Randomly collide with the wall of the container, rebound elastically. All those are physics terms here, creating a change in momentum, hence pressure. And then those wordings will be new, and you will be always using this to explain more frequently and more violently for the collision, so that you have greater pressure. Then those will be the wordings that we expect to see when we are explaining. And that's it for the whole small point for kinetic theory. And we have the upcoming questions here. I want you to try it first before we check it. And at the very beginning, we will not check the answer. I want you to try it first, and we will be focusing on all those concept points first. And after we have finished all the concept points, we will come back and I will demonstrate all the questions for you, and we can check together in another video.